Hey there guys, welcome to my walkthrough of the AQA November 2017 Higher GCSE Maths Paper 2. So you can get the paper and the mark scheme from the AQA website. You can find a link to my playlist containing every walkthrough to every AQA Higher GCSE Maths past paper down below in the description, as well as other bits and bobs to help with your GCSE Maths revision, and useful topic playlists and videos to help with things on this paper. Let's go. Okay, question 1 wants us to circle the fraction equivalent to 3.875. So, straight away, our calculators can do this for us. Stick in the decimal, press equals, and it should turn it into a fraction. And you should get 31 over it. Question 2. What is 50 as a percentage of 20? Okay, so with any number that you want to find as a percentage of another number, we do the first number divided by the second. So 50 divided by 20, now that would give us 2.5, and then we multiply that by 100 to get 250%. Okay, question 3. Circle the point that does not lie on the curve y equals x cubed. So, what that means is there will be a set of coordinates here where the x coordinate cubed does not give us the y coordinate. So, let's try this first one. So, minus a half cubed does indeed give us minus 1/8. So that one does. 5 cubed does give us 125. So that one does. 1/3 cubed will give us 1 over 27. So this one doesn't work. This is the one that does not lie on the curve. Okay, question 4. Which one of these is a unit of density? So, density tells us how heavy something is per a certain amount. So it's mass over volume. So, this first one is kilograms over meter squared. That's mass over area. Nope. Next one, meter squared over kilogram is area over mass. Nope. Third one, kilogram over meter cubed is mass per volume. That is our guy. And then the last one, it would be volume over mass. So, no good. Okay, question 5 wants us to solve for lot of 3x minus 2 is equal to 2x minus 5. So, expand the brackets, we're going to get 12x minus 8 is equal to 2x minus 5. Now we want to get the x's on the same side, so let's subtract 2x. So we get 10x minus 8 is equal to minus 5. Now we want to get the x term on its own, so we need that minus 8 to bugger off. So we're going to add 8. So 10x is minus 5, add 8, which is 3. and then divide by 10, x is 3/10 or 0.3. Cool. Okay, question 6. The graph shows information about prisms with the same volume. So going up the side, we have the length in centimetres, and going along the bottom, we have the area of the cross-section. Part A wants us to give one example to show that the volume is 24 centimetres squared. So, volume of a prism is equal to cross-section area times the length. So, let's just pick a value. I don't know, we want to show that our volume is 24, 6 goes into 24, so let's go up from a cross-section of 6 and then go across, so we would hit there, ignore my rubbish drawing, and then let's go across to see what the length would be. So it would be 4. So we can literally then just say 6 times 4, or 6 centimetres times, 6 centimetres squared, times 4 centimetres is 24 centimetres cubed. Okay, then for part B, the diagram shows a prism with a volume of 24 centimetres cubed. The height of the triangular cross-section is h. Our job is to work out the height h. So we also know the base length is 6. Now, we've just said that volume is cross-section times length. So, given that the height is part of the cross-section, it makes sense to get the cross-section on its own. So if we divide through by the length, cross-section is volume divided by length. So here that's 24 over 5. Now that's going to give us 4.8, and that is centimetres squared. So that's given us the area of the triangle. Now the area of a triangle is base times height over 2. Now we know the base is 6, so 6 h over 2 is equal to 4.8. On the left, 6 over 2 is 3, so 3h is 4.8. Divide by 3, h is 1.6 centimetres. Cool. Okay, question 7 wants us to describe fully the single transformation that maps triangle A onto triangle B. So, we can see that triangle A has got smaller, so that means it's an enlargement. Now, how much smaller? Well, A had a base of 1, 2, 3, 4, 5, 6. B has a base of 2, so the scale factor is a third. And then we also need to know the centre of Enlargement. So to find the centre, we join up corresponding points of the triangles. So for example, we're going to join that point to that point and keep the line going. So as expected, it's not gone too smoothly. Okay, and then we do that with another 2 points on the triangles. And where the lines meet is the centre of enlargement. Cool. So we can see the centre would be this point here, which is at 5, 1. Now we should have got 3 marks for that. Yep, cool. 3 marks for saying 3 things. Okay, question 8, we have a grouped frequency table. So the table shows information about the distances walked by 120 students on the way to school in 1 week. So we were asked to work out an estimate for the mean. So we got 2 empty columns in the table. So the first one is for the midpoint of each interval. So the midpoint of 0 and 5 is 2.5. 5 and 10 is 7.5. 10 and 15 is 12.5. And 15 and 20 is 17.5. Now for the other column, we now do the midpoint times frequency. So the reason we take the midpoint is because it's an estimate for the average from each interval. So what we do now is multiply that by the frequency to get an estimate of the total distance walked by the people in each interval. So 20 times 2.5 is 50. 48 times 7.5 is, bear with, 360. 30 times 12.5 is 375. And then 22 times 17.5 is 385. Okay, so now we add those 4 together. So we're going to get 385 add 375 add 360 add 50, and we get 1170. Now to get the mean, we do 1170 divided by the number of students. So divided by 120. And that gives us 9.75. Cool. Okay, question 9 wants us to work out the size of angle X in this right-angled triangle. So this is SOCTOA. If you need any more practice on this, I'll put my playlist down below, as well as my frequency table stuff too. So, with regards to the angle, this side is the opposite, this side is the adjacent. So we go to SOCTOA to work out which function we want. SO, S-O-H, no, CA, C-A-H, no, TOA, T-O-A, bingo. So, TOA tells us tan of X is equal to the opposite, so 3 over the adjacent 7. Now to get an angle out of trig, we use the inverse trig function on the fraction. So press shift and tan, we get x is the inverse tan of 3/7, which gives us 23.198. So I would round that to 23.2 degrees. Okay, question 10 wants us to work out the next term, not the nth term of this quadratic sequence. So, to do that, we need to have a look at what's going on. So to get from 5 to 8, we add 3. From 8 to 14, we add 6. From 14 to 23, we add 9. So we can see here our differences are going up in 3s. So next we're going to add 12, which gets us 35. Cool. More on that in my sequences playlist down below. Question 11 wants us to circle the expression that is equivalent to 3x squared over 6x squared add 3. So there is a one common factor running through this, which is 3. So we can divide everything through by 3. So we're going to get 1x squared on top over 2x squared add 1 on the bottom. Nothing else we can do. So, there's our guide. Okay, question 12. The table shows information about UK and Germany. So we got the populations and the area in square miles. We're told population density, so a nice bit of geography here is population divided by area, and we are asked to compare the population densities of the UK and Germany. So, for the UK, the population density is 64 million divided by 95,000. Now that's going to give us 673.7 Now if we do the same for Germany, so we're doing 82 million divided by 140,000. And that's going to give us 585.7. So there are our two population densities, that's 2 marks. We now get 1 mark for comparing them. So we could say Germany is less densely populated than the UK. Cool. Okay, question 13, we got a bit of geometry. So 2 straight lines meet at point P. We want to find the coordinates of P. So our 2 lines are y equals 3x and y equals minus 1. So at this point, these 2 lines are simultaneous. When you solve simultaneous equations, this is what you are doing. You are finding where 2 lines or a line and a curve or a circle meet. So we know that y is equal to 3x. So whatever the x coordinate here is, y is 3 times it. And we also know that y is minus 1. So we know the y coordinate already is minus 1. Now, given that we know that y is minus 1, we can substitute that into y equals 3x. So we can say minus 1 is equal to 3x. Dividing by 3 gives us minus a third is equal to x. That's it. That's our x coordinate. So the coordinates are minus a third minus 1. Which is this guy. Okay, question 14. A ball is thrown from a height of 15 meters. It bounces and reaches H1, and then it bounces again to H2 as shown. So we got our ball being thrown, hits the ground, bounces back up to H1, hits the ground, bounces back up to H2. H1 is 3/4 of the original height. Jack expects H2 to be 3/4 of H1. Parte, for 2 marks, 1 says 2, work out the value of H2 that he expects. Okay, so H1 is 3/4 of 15. Now I'm just going to leave this as a fraction until the end. So 3/4 of 15 means 3/4 times 15, which is 45 over 4, which I suppose we could say is 11.25. It's not as horrible as I thought. So then H2 is 3/4 of, okay, let's just use 11.25, which is, bear with me, 8.4375. Cool. Okay, then 14b says, in fact, H2 is 2/3 of H1. How does this affect our answer to part A? So does the ball bounce higher, unexpected, or lower? Well, 2/3 is less than 3/4. So 2/3 of 11.25 is less than 3/4 of 11.25. So it's going to bounce lower than expected. Now it says, show workings to support your answer, so you could work out the actual height of H2. You would be fine just saying that 2/3 is less than 3/4. Cool. Okay, question 15, we have compound interest. So Marek invests £6,000 at compound interest rate of 1.5% per year. He wants to earn more than £1,000 interest. Good luck. We want to work out the least time in whole years that this will take. So, trial and error, really. So, we do need to use decimal multipliers. So, 1.5% divided by 100 turned into a decimal is 0.015. So the formula that we're going to use is 6,000 times 1.015 to certain powers of t. So the first one that I tried was 10. It seemed sensible. So if we went to the power of 10, he's going to have 6,963. So it was quite a good guess because that's getting very close. So then I tried 11. So 6,000 times 1.015 to the power of 11 was 7,067. So after 11 years, he's made 1,067. There was pence as well, but we don't really care. Interest. All that we care about is that he has now made more than £1,000. So the answer is 11 years. Cool. In question 16, we got some algebra. So part A, factorise fully 9y cubed minus 6y. So when they say factorise fully, they are giving you a little clue that there is more than one common factor inside. So, first up, we can see there is a common factor of 3. So if we take that up, we get 3 times 3y cubed minus 2y. Now the other common factor is y. So we take our factor of y, so we get 3y, lots of 3y squared minus 2. Cool. Okay, then part B, wants us to factorise a harder quadratic. So I got more examples of this in my quadratics playlist, which will be down below. So we got 3x squared minus 22x add 7. So, given that we got a 3x squared, one bracket needs a 3x. The other bracket needs an x. So that's our 3x squared taken care of. Now we have a negative number in the middle, but a positive number at the end. That tells us both numbers must be negative, and they need to multiply together to give us 7. So only two numbers do that, 1 and 7. So if we put a minus 7 there, minus 7 times 3x is minus 21x, and then minus 1 in there gives us another minus x, which gives us minus 22x. Cool. Okay, question 17. Now I know this one caused a lot of problems, mostly because people don't know how to work out the area of a parallelogram. It's exactly the same as a rectangle. So the area is base times height. Now the only problem is that we don't know the height of the parallelogram, but we can work it out. So if we draw a line down like that, we've just created ourselves this cheeky little right angled triangle. Now we know an angle, we know one side length, we can work out another side length. So the height is the opposite, 12 is the hypotenuse. So to SOHCAHTOA again, S-O-H, yes. So we know sine 72 is O, or the height, over 12. So O is 12 sine 72. Now that gives us 11.4. So we now know the height is 11.4. So the area is base, which is 16 times 11.4. And that is going to give us 182.6 centimeters squared. Again, that formula is in my formula sheet, which you can get to the video and the PDF down below. Okay, question 18, we have Venn diagrams and set notation. So, we're asked which of the following represent this shaded area. So let's have a look at what we got. So, is it A? Well, A would include the intersection, which we can see is not shaded. So it's not A. Is it B dashed? Now B dashed means not B. So again, that's no, because that would include the outer rectangle as well. So it's not B. Is it A and not B? So yes it is, because the A circle is shaded, but not the part that contains B. So it is A and not B. Okay, then the same job. Down here we want the shaded region. So everything inside of the circles, so this region in here is A union B. So everything on the outside is A union B dashed. So it's not A union B. So that's the guy that we want. Right there. Cool. Okay, question 19. We have forming and solving an equation. So we're told the length of a rectangle is 5 times its width. The area of the rectangle is 1620 centimeters squared. And our job is to work out the width of the rectangle. Okay, so we are told the length is 5 times the width. So what do we like to call things in maths when we don't know what they are? Other than a pain in the ass, we like to call them x. So let's call the width x. Now the length is 5 times the width, so that is 5x. So we know the area algebraically is 5x squared. Now we know the area numerically is 1620. So that means then 5x squared is 1620. So x squared is 1620 divided by 5, which is so 5 into 16 goes 3 times, 1 remainder, twice 4. So 324. So to get x, we now square root. So x, or width, is the square root of 324, which is going to give us 18. So the width is 18 centimeters. Cool. Okay, question 20, we have proportion, so I'll put my playlist down below. So a stone is thrown upwards with a velocity of v meters per second. The stone reaches a maximum height of h meters. H is directly proportional to v squared. So straight away, I'm going to write down h is proportional to v squared, and the formula then would be h is k v squared. We're told that when v is 10, h is 5, so we can use that to work out the value of k. So, when v is 10, h is 5. So, v is 10, h is 5. It's going to give us 5 is equal to k times 10 squared. So 100k. Now if we divide by 100, we get k is 5 over 100, which is 1/20. So at this point, we now know h is 1/20 of v squared. Now the question wants us to work out the maximum height when v is 24. So, when v is 24, h is 24 squared divided by 20, 1/20th times 24 squared. So 24 squared is 576. So we get 576 over 20, which is going to give us 28.8 meters. Cool. Okay, question 21. Mina is using a graphical method to solve 2x squared minus 3x is equal to 0. She draws the graph of y equals 2x squared and a straight line graph on the same grid. Here is the graph of y equals 2x squared. Now we want to complete a method to solve 2x squared minus 3x is equal to 0. So we need to draw a straight line. Now what straight line do we need to draw? Well, notice that we are solving 2x squared minus 3x is equal to 0. So we can add 3x to both sides. So we would get 2x squared, which is the curve, is equal to 3x, which is the straight line that we want to draw. Remember, when we solve simultaneous equations, we are finding points where lines and curves, or lines and lines, intersect. So, if we draw the line of y equals 3x, we will see the 2 points where it hits the curve. So, for y equals 3x, if we draw a little coordinate table, we know x, y. When x is 0, y is equal to 0. When x is 1, y is 3. When x is 2, y is 6. So if we plot those points, we've got 0, 0, we've got 1, 3, and then we've got 2, 6, which is going to be this point here. Okay, so now we want to draw the line that goes through these 2 points. Now what we need are the 2 points where it hits the curve. Okay. Let's just sharpen that up a little bit. Okay, so that should do it. So now we've done that, we can solve. So what we want are the x values where the line and the curve intersect. So we get x is equal to 0, and the other one is here, which is going to be x is equal to about 1.5. Cool. Okay, then for part B, Lewis is solving 2x squared at 5x is equal to 0. He uses this method. Now what we want to do is evaluate his method and his answer. Okay, so he's written the equation down. That's always a good start. He subtracts 5x from both sides. Okay, nothing wrong there really. So now he's spotted that there's a common factor of x on both sides. So he divides both sides by x. Now, this is a problem. But if we carry on, he's then got 2x is minus 5. Then he divides by 2 to get x is minus 2.5. So, the answer is right. It's just not the whole answer. So he doesn't have the whole answer. So that is not the whole answer. What he's done is, by dividing by 0, by dividing by x, he loses a solution. So what he should have done is, when he had 2x squared and 5x was equal to 0, he should have factorised. So he would have got x lots of 2x and 5 is equal to 0. So then we get our two solutions from that. So we would have got x is equal to 0, or 2x and 5 was equal to 0, which would have given us 2x is minus 5, so x is minus 2.5, which is the one that he got, but he lost x equals 0. Okay, question 22, a 95 marker. So we got the cross-section of an earring is a semicircle, centre C with a radius of 25 millimeters. The earring is black and white. The shaded area is black. So we've also got this white sector. Now we're told that sector BCD is white and has radius 12 millimeters. Now we got a drawing of it here. So the angle is 150 degrees. We are asked, is more than 20% of the semicircle white? We must show our workings, and it's 5 marks. So, let's first of all work out the whole area. So the whole area is a semicircle with radius 25 millimeters. So the area of a circle is pi times the radius squared. So the area of the semicircle is pi times 25 squared all over 2. Now, I'm going to leave these in terms of pi until the very end. So 25 squared is 625. So we got 625 pi over 2, which gives us 312.5 pi millimeters squared. So that is the area of the whole earring. Okay, now let's do the white sector. Okay, so first up, the angle is important. So the angle tells us what fraction of the whole circle the sector is. So the sector is 150 over 360, because angles around a point total 360, so the sector is 150 360ths of the circle. Of the circle with radius 12. So 150 360ths is 15, and 36 is 5 twelfths. So the area of the sector is 5 twelfths times pi times 12 squared. So we got 5 twelfths times pi times 12 squared, which is going to give us use your calculators and you will get 60 pi millimeters squared. So now we know then that the white area is 60 pi out of the whole area, which was 312.5 pi. Now that, as a decimal, is going to give us 0.192. Now 0.192 is 19.2%. So the question asked is more than 20% of the semicircle white? So the answer is no. Cool. Okay, question 23, we have a histogram showing us information about members of a tennis club. So there's our histogram. We got frequency density upside, but we got no scale. It's going to be part of the question. So we're told there are 30 members with age less than 20. So we got age going along the bottom. There are 12 members with age greater than or equal to 65 but less than 80, and there are no members with an age greater than 80. Part A, 3 marks, wants us to complete the histogram. So, crash course in histograms. In the area of each bar, so along the bottom you got interval width. Upside you have frequency density. Inside the area represents the frequency. So frequency is equal to frequency density times the interval width. So what we need to do here is find our scale for our frequency density. So what we know is that there are 30 members with age less than 20. So we know the area of this first bar has to be 30. Now we have an interval of 20. So we know from that 20 times the frequency density has to equal 30. So if we divide by 20, frequency density is 30 over 20, which is 1.5. So that tells us the frequency density up to here is 1.5. Now we have a scale for our frequency density. So each tiny little square is going to represent 0.1. Now what we need to do is draw the bar for the people between 65 and 80. So we know there are 12 people. The interval is 15 wide, so we know 15 times frequency density is equal to 12. So the frequency density is equal to 12 over 15, which gives us 0.8. So the box is 15 wide and 8 high. So 8 little squares. Just going to be there. So there is our completed histogram. Cool. Okay, then part B wants us to work out the total number of members in the club. So we know already we got 30 add 12. What we need to do is work out how many are in these bars in between. So this second bar has an interval of 10 and the density of, to fill this in, so we got 2, 2.5, 3, 3.5, 4, 4.5, that's as far as we need to go. So in this second bar, we got 10 times 4.5, there are 45 people in there. And then in the next one, again the interval is 10. Our density is going to be one little square above 3.5, so 3.6, so that's going to be 36. And then in the last one, our density is 2 and our width is 40 to 65, so 25. 2 times 25 is 50. So let's add all of those together. So 30 add 12 is 42, add 45 is 87, add 36 is 93, 123, add 50 is 173. Question 24, we have a speed time graph. So Beth ran a 200 meter race. We got the graph of her first 8 seconds of the race. We're told she completed the race at a constant speed of 9 meters per second. Amy completed the race in 27 seconds. Did Beth finish before Amy? We must show our working. So we got time along the bottom, speed up the side. So what we need to remember here is that distance is the area under the graph, and also speed is distance over time. It's going to help us too. So let's work out how far Beth has run in the first 8 seconds. So we want to work out the area of this triangle. Good to see my drawing. It is amazing, as always. So, this triangle has a base of 8 and a height of 9. So, in the first 8 seconds, the distance travelled is the area of this triangle. So 8 times 9 divided by 2. So that's going to give us 36. So she's ran 36 metres up to here. Now that means that there is 200 minus 36 left to run, which is 164 metres left. Now we know she's doing the rest at 9 metres per second. So what we need to know is how much time it takes to complete the race. So speed is distance over time. If we multiply by time and divide by speed, we get time is distance divided by speed. So we need to do here 164 divided by 9. So if we smash that into our calculators, we get 18.2 seconds. So her total time is the first 8 seconds at 18.2 seconds, which is going to give us 26.2 seconds. So we were asked, did Beth finish before Amy? Amy took 27 seconds. So the answer is yes. Cool. Okay, question 25, we have bounds. So a rectangular floor, or the dimensions of a rectangular floor, are given to the nearest 0.1 meters. Cool. We're told a force of 345 newtons is applied to the floor. The force is to the nearest 5 newtons. We're told that pressure is force divided by area. We want to work out the upper bound of the pressure. Giving our answer to 4 sig figs, we must show our working. Okay, so the upper bound of the pressure, let's call that pressure PU. Okay, so pressure is this fraction, force over area. For a fraction to be as big as possible, we want the biggest number on top divided by the smallest number on the bottom. So we want force upper divided by area lower. So the upper bound of the force divided by the lower bound of the area. So the greatest possible force divided by the lowest possible area. So, our upper bound of our force is going to be, well, it's 345 newtons to the nearest 5. So the upper bound of that is going to be 347.5. So you use the upper bound as the first number that wouldn't round down. So that's our upper bound. Then we need the lower bound of the area. So we want the smallest possible lengths of the rectangle. So the smallest possible number that would round to 6.4 to the nearest 0.1 would be 6.35, and for the height we would have 2.55. So it's going to be 2.55 times, forgotten the other one, 6.35. Now that is going to give us 16.1925. So, the upper bound of our pressure is 347.5 divided by 16.1925, and that is going to give us so to forcing things, we're going to get 21.46 newtons. Sorry, it's pressure, 21.46 newtons per meter squared. Cool. Okay, question 26, we got vectors, yay. So, ABCD is a pentagon. Our job is to show that BCDE is a parallelogram. So, first up, where is BCDE? It's this shape here. So, what we need to do is show that. So we need to need BE to be parallel to CD. So we need BE and CD to be parallel. And we also need BC and ED to be parallel. Okay, so we've got some vectors to work out. So let's first of all let's do BE. Okay, so how do we get from B to E? Well, we're going to start at B. We're going to go along A up to point A and then across to E. So that's A add to B. Okay, let's then do CD. So, CD, how are we going to get from C to D? Well, we are going to go backwards along B minus 2A up to E. So if you go backwards along a vector, you are doing that negative vector. So that's going to be minus B add 2A. And this is for C to D. Okay, and then when we're at E, we're going to go backwards along A minus 3B. So that's going to be minus A add 3B. Okay, now that's going to give us, we got 2A minus A. So that's A. And we've got minus B add 3B, which is plus 2B. So at that point, we can say BC and CD, BE and CD are parallel and equal length because they are exactly the same vector. And same length. I think my brain is dead. And same length. Okay, now let's do the same for the other two sides. So let's look at BC. So, to get from B to C, we're going to have to go up to E. Now we already know that that's A add 2B. And then when we're at E, we're going to go across down to C. So then it's going to be add B minus 2A. So that's going to give us, we got A minus 2A, so that's minus A, and then we got 2B and B, which is 3B. Okay, now we just need to find E to D. Now that's good, because we know that E to D is going to be 3B minus A, or minus A add 3B. So E to D is minus A add 3B. So that tells us BC and CD are parallel and the same length. So we got two pairs of parallel same length sides. So B, C, D, E is a parallelogram. Go. Okay, question 27, the final question. 6 marks. Big question. So, an equation involving algebraic fractions. We're going to need the quadratic formula. It's going to be a whole heap of fun. Okay, so we want to solve x over 4 minus 2x over x add 2 is equal to 1. Giving your answer or solutions to 2 decimal places, we must show our working. So there's a good hint in there that this is going to turn into quadratics because it says giving our solutions to 2 decimal places. Right, okay, so we got x over 4 minus 2x over x add 2 is equal to 1. Right, quite a few ways we could go about this. What I'm going to do is multiply the whole equation through by each of those denominators one at a time. So I'm going to first of all multiply through by 4. Now remember, fractions are a division by the thing on the bottom. So x over 4 means x divided by 4. So if we come along and multiply everything by 4, we're going to get left with x minus 8x, because that 2x gets multiplied by 4 over x add 2 is equal to 4. Okay, then I'm going to multiply through by x add 2. So that's going to give us x times x add 2 minus 8x is equal to 4 lots of x add 2. So, we got rid of the fractions, it looks nicer. Now expand the brackets. So we're going to get x squared add 2x minus 8x is equal to 4x add 8. Now, it's quadratic, so as with any quadratic, we now need to get everything on the same side with a 0 on the other. So, if we, let's just sharpen up the left hand side of it. So we got x squared, then we got add 2x minus 8x, so that's minus 6x. That's equal to 4x add 8. Now we're going to subtract 4x, so x squared minus 10x, and we're also going to subtract the 8, so minus 8 is equal to 0. So there is our quadratic that we need to solve. Now there's a good clue here that we can't factorise this, and that is that it told us to give our answers to decimal places. So that is screaming either quadratic formula or completing the square. So let's use the formula. So A is 1, B is minus 10, C is minus 8. Now again, this formula can be found on my formula sheet, which you can get down below, as well as the formula video. So the quadratic formula is x is equal to minus b plus or minus root b squared minus 4ac all over 2a. So for us, we're going to get x is minus 10, so positive 10, plus or minus root minus 10 squared, which is 100, minus 4 times 1 times minus 8. So that's going to be plus 32, b squared is going to give us 100 plus 32, so we get root 132 all over 2 times 1, which is 2. So x is 10 plus root 132 all over 2, which I'll get in a moment, and x is 10 minus root 132 all over 2. Okay, so our two values of x are 10.74 and minus 0.74. And with that, paper done. Hope you found this useful, guys. Don't forget, you can get to every AQA past paper down below. All sorts of useful stuff in the description. Hope you found this useful. Please get subscribed. Good luck in your exams. Take it easy. Take care.